Functions can be represented in 4 different ways: verbally, symbolically, numerically, or graphically. So the symbolic form is like a formula. Numerically, we're usually thinking about a table of values, and then graphically, we can also represent a function. So here's an example that's given in verbal form, and we're going to translate it into a symbolic, numerical, and graphical representation. So what does it say? Multiply the input x in feet by 12 to obtain an output y in inches. Okay, so this is a function. Verbally, it's telling us that we're going to take an input that's in feet and our output is going to be in inches. So to get that to happen, it even told us. They said, okay, let's multiply the input x by 12. Okay, so if we multiply x by 12, that's 12x. Yes? So we have a function in symbolic form of f of x equal to 12x. Now, hopefully this makes sense since there are 12 inches in a foot, right? So if we multiply 12 times the number of feet, we should get the number of inches. Numerically, we can also think about this. Doesn't make sense to have a negative distance, so I'm going to start at 0 here for x values. 0 feet, 1 feet, 2 feet, 3 feet, and 4 feet, right? So to fill in the f of x values or the y values, we're simply putting in these x values into this function. So for instance, when x is 0, the output is also 0, right? Because why? Because f of 0 is equal to 12 times 0, right? And what do we have over here? F of 1 would be equal to 12 times 1, or 12, right? So if we multiply 12 by 2, we get 24. If we multiply 12 by 3, we get 36. If we multiply 12 by 4, we get 48, right? So the inputs here represent number of feet, and the outputs represent the number of inches corresponding to that number of feet. Okay, so let's take a look at this graphically. Get a little graph going. I'm not going to include negative values of x or y because our x and y values are both positive, and our x values range from 0 to 4, right? So I'm going to scale that accordingly, right? And make sure you label the axes here. And also this is in feet, right? Our x values. Okay, so whenever you have a context to the problem that you can add, make sure that you label the axes accordingly. For the vertical axes up here, I'm going to have f of x, or the y value, right? And I've got 0 to 48, right? Well, gosh, I don't have that much room here, so I'm going to scale it a little differently, and I'm going to scale it by 12s. Right? You don't have to scale it by 12s, but given that that's what it's increasing by, that'll make our graph easy here. Okay, so 12, 24, 36, 48, and this is in inches, right? Inches. Okay, so I'm starting at 0, 0, 112, 224, 336. Now, how many points do we need to graph a line? Because this is linear. Not that many, right? Only 2. But we graphed 4 points. So notice the scale of this, how that affected visually the graph. If we had actually scaled the y-axis with each tick mark being 1 unit, the graph would look much steeper than it does in this particular representation. But we've got the idea, right? It's a linear function. For each increase in 1 foot, the y value increases by 12 inches.